permutations. Permutations, the order matters. It's like picking a president, a vice president, and a secretary. It's different if I pick me for the president and Leanne for the vice president and Mariah for the secretary, or if I went in the reverse order and made Mariah the president and you the vice president and me the secretary. Those are two different things. So when you have a permutation, the order matters. Formula for permutation. Again, if I have n things and I'm taking r of them, I'm going to have n factorial divided by n minus r factorial. So suppose that a code consists of 4 digits, none of which is repeated. A digit is one of the numbers, 10 numbers from 0 to 9. How many codes are possible? So 1, 2, 3, 4 is different than 4, 2, 3, 1, right? I'm going to do a permutation. I have 10 digits to choose from. I'm going to do 4 of them. So I am going to do 10 factorial over 10 minus 4 factorial, which would simplify into 6 then, right? Same thing, instead of going all the way from 10 down to 1, I'm just going to go to 6 factorial. So 10 times 9 times 8 times 7 times 6 factorial, and then I can cancel out the 6 factorial. And so we're going to end up taking 10 times 8, 10 times 9 times 8 times 7.
5,040.
5,040. Number 11, a company has 11 salespeople. A board member at the company asks for a list of the top 5 salespeople ranked in order of effectiveness. How many lists are possible? Assume that the order of the salespeople on the list is relevant. It makes a difference who's first, second, or third. So, again, we're doing a permutation. We have 11 salespeople. We're going to do the top 5. And so we're going to do 11 factorial divided by 11 minus 5 factorial. 11 minus 5 would give us 6 factorial, right? So starting with the 11, 11 times 10 times 9 times 8 times 7 times, there's my 6 factorial that I'm going to be able to cancel off my list. So we end up taking 11 times 10 times 9 times 8 times 7, which is 55,400, did you say? And 40. Number 12, 14 athletes are running a race. A gold medal is to be given to the winner, silver to the second place, and a bronze to the third place. Assuming there are no ties, how many possible ways can the 3 medals be distributed? So again, the order is important. First is different than second, which is different than third. We're going to do a permutation. 14 people, we're giving out 3 medals, first, second, and third. So 14 factorial over 14 minus 3 factorial, which would be 11 factorial. So we're going to have 14 times 13 times 12 times our 11 factorial, which is going to cancel out. 2,184. Now, much like your combination, we can do the permutation in the same way. We first are going to start by putting in that first number. I'm going to get back on my home screen if I'm not on there already. So it doesn't matter if you have the other one in there. You can clear out your home screen if you want, but it won't matter. I'm going to put the 14 in first. I'm going to hit the math button. I'm going to cursor over to the probability. And number 2 is your permutation choice. Once I have that on my screen, I'm going to put in the number for how many I'm choosing. In this case, 3. And if I hit enter, I should get 2,184. interesting math. Cursor over to the PRB. Number 2 is your permutation. And then put in your 3 that we were using for R and enter. Or, yeah, enter. 2984. You have directions under your technology stuff in your big binder of whatever on how to do that.